Hello, I've had a question in the 3U Physics, Unit 5, Lesson 4. And I'm looking at question 35C, and this is the circuit analysis. So with the circuit analysis, I always like to set up my chart first. So I have V, I, and R as my categories. And I have 1, 2, 3 parts of the circuit that I'm going to analyze. So making a nice, neat chart. 1, 2, 3. And then at the bottom, I'll put my totals, and I fill in whatever information is provided. So that first thing I see is that the total voltage, the energy provided by the battery, is 50, so I can fill that piece of information in. At circuit number 1 here, I can see that I have a resistance of 25 ohms. I see similarly resistor number 2, it's got 15 ohms. And I know the resistance at number 3, which is 10 ohms. So I don't have enough information. I need to know 2 pieces of information in a line to find the third. So what I need to do is now find the total resistance for the circuit. So I'm going to crush this down into one circuit. So I'm going to have my battery, and I'm going to create one resistor over here, meaning that this is going to become resistor 1, 2. So 1 and 2 get combined. This one remains 10 ohms, 50 volts, and so on and so forth. So how do we combine resistors 1 and 2? Well, they're in parallel, these two resistors. So that means that 1 over my total resistance, or 1 over R12, is equal to the resistance of 1 over R1 plus 1 over R2. So that would mean that 1 over 25 plus 1 over 15, and you can just use your calculator, the fraction option, or with the brackets. So I have a 25th plus a 15th. That gives me 8 75ths. But now I want this as just R12. So I flip that fraction, and I get, let's call it 9.4 ohms. 1 decimal place is sufficient for what we're doing. So that means that I now know the total resistance here around the circuit, because there's only one pathway. So that means my total resistance, RT, in a series circuit is the sum of my resistances. So that means that my resistance for this circuit in total is 19.4. So in the chart, my total resistance is 19.4. I know that V equals IR, so my total voltage is 50, so the total current for this circuit can now be calculated. So I know that the current, or the total current available, is I'm going to go with 2.6 amps. 1 decimal again is good enough. So there we go. Now we have some information to move forward. So we look at our diagram, and anywhere there's a single pathway, all of this current has to go through a single pathway. So here, the current splits, and I don't know how yet. So I'm going to skip over that, and I'm going to go to resistor 3. All my current has to go through here. There's no options. So that means all of the 2.6 amps is going to go through that resistor. That means now I can find the voltage, or how much energy the third resistor consumed. So that's just multiplication. So I know that 26 volts, 2.6 times 10, the 26 volts were used to get through here. So our voltage here is 26 volts. That means that I started with 50, that was my total. 26 volts are being used over there. So I have 24 volts remaining. All right, here's the trick. When I get to this point here, let's call it point A, I want to get to point B. I have 2 options. I can go this direction, or I can go this direction. I can't go back and start over. So there's only one possible pathway here. So if I go this way, I have to use 24 volts. If I go this way, I have to use 24 volts. So that means that the voltage at resistors 1 and 2 are both going to be 24. All right, because when you go around this circuit as an electron, you have to use up all your voltage. You know you're using 26 volts here. If you go path 1, you have to use your remaining volts of 24 or 24 here. So now we just do our calculation. 24, and I'm going to have to go divided by 25. So 0. I'll go with 2 decimals here. 0.96, 24 divided by 15, 1.6. And if you're to add those together, your current, all right, these two, this is where the current split. These two add up to 2.6 if you added them together. They add up to the total current. So the current split 1 to 1.5 roughly. All right, so there's your chart completely analyzed. The key is determining how much voltage you have remaining when you get to one of those parallel circuits. If you have any further questions with that, let me know, and I will try to clarify.